Can we use PCA or principal component analysis for feature selection? Simple answer, no. Now let's go through it in detail. PCA is primarily a dimensionality reduction technique, but it is not explicitly used for feature selection. However, it can be useful in the pre-processing stage to aid in feature selection. So PCA works by transforming the original features into a new set of linearly uncorrelated features called principal components. These principal components are linear combinations of the original features and are ranked in order of decreasing variance, with the first principal component accounting for the largest variance in the data, then the second principal accounting for the second largest variance of the data, and so on and so forth. By selecting a subset of these principal components, we can retain most of the variance in the data while reducing the dimensionality. Now, what do I mean that the principal components are linear combination of the original features? Suppose we have a dataset with three features: height, weight, and age. Now, in PCA, we aim to find a new set of variables that are linear combinations of the original features. Let's say we have two principal components, PC1 and PC2, represented with this formula: PC1 equal to A1 multiplied by height plus B1 multiplied by weight plus C1 multiplied by age, and PC2 represented A2 height, B2 weight, and C2 age. And here the coefficients A1, B1, C1, A2, B2, C2 represent the contribution of each of the original features to the principal component. These coefficients are calculated such that the variance explained by each principal component is maximized. The principal components can be used to represent the original dataset in a lower dimensional space. We can project the original dataset into the principal components to obtain a new dataset with fewer dimensions, which are PC1 and PC2 in this case. This new dataset will have the same number of samples as the original dataset but with fewer features. Now let's dive into the reasons why PCA is not considered a feature selection technique. First point is loss of interpretability. The principal component are linear combinations of the original features, which means that they do not retain the original features' interpretability. As a result, it can be challenging to interpret the results from a model that use principal components as inputs. In contrast, feature selection methods like filter or wrapper methods retain the original features and are more interpretable. Second point is linearity. PCA is a linear technique, which means it assumes a linear relationship between the original features. These assumptions may not hold for all datasets. Feature selection technique do not make such assumptions and can be used with linear or non-linear models. However, PCA can be useful in the pre-processing stage before feature selection for the following reasons. First, noise reduction. PCA can help remove noise from the dataset by capturing the most significant variance in the data while discarding the low variance components which may represent noise. Second one is correlation reduction. PCA transforms the original features into a new set of linearly uncorrelated features. This transformation can help with feature selection methods sensitive to multi-collinearity, such as lasso or ridge regression. In summary, PCA is not considered a feature selection technique as it creates linear combinations of the original features, leading to a loss of interpretability and assumption of linearity. However, it can be useful for pre-processing step to reduce noise and multicollinearity in the data, thereby aiding the feature selection process.